This next question is up for grabs. Anybody on the panel? What is the profile of a customer who is an early adapter for projects that support ESG requirements?
I could probably try to take a stab at that.
There you go. You're up.
ESG is across the board being driven, as you know, from the top down. And the early adapters are those who are kind of, and there are certain folks in the industry who are purposely not first movers, who lay back. That what they're finding is that they're suffering in terms of multiple valuations for their companies. So the early adapters really, there's a lot of opportunity for the power producers in terms of repowering, especially going from coal to either peak or combined cycle. There's a tremendous amount of opportunity for hydrogen to really enhance the permitting capability, and that combined with PER can really put the project over the finish line in terms of regulators, both local, state, as well as federal regulators and the FERC.
Great, thank you so much.
I can add something to that
Sure.
too. When we think about our customers, we think about them in two brackets. One are the customers that talk a lot about clean energy and ESG to put it in the annual report. And then there's the customers that put resources behind it and who go beyond just talking about it and putting it in the annual report and actually make the investments. And it's an important distinction for us as, like I said, a pre-revenue startup, because we only have so many resources. So we have to be super focused on going after the companies that put resources behind clean energy investments, not the ones that talk about it.
Right, great, thank you. I'm gonna stay with you, Mike. How much power can the turbo expander generate?
Yeah, so each turbo expander generates 500 kW. It's rated for 520, but the output is 500 kW.
Right.
Our systems can generate as much power as the gas conditions can support. And what I mean by that is, since these are modular systems, we just stack them, right? So there's a site we're looking at in Indiana that can support 12 turbo expanders, so total capacity of 6 megawatts.
Thank you. All right, Jeff, you're up.
All right.
For the digester, the CO2 is captured and sold. For your hydrogen plant schematics, the oxygen is vented. Are there credits to vent oxygen to the atmosphere? Or is the oxygen capture and sale not economically viable?
Yeah, we've looked at different options, and the oxygen, I don't believe there's any credits for just admitting it to the atmosphere, but at certain locations where there's oxygen demand, you can capture it and sell it as a additional product. Okay. So, but that's more site specific. If you're in a remote area,
right,
probably not worth the effort, but if you're adjacent to an industrial facility or close by, it could be another revenue stream.
Great, thank you. This next one's up for grabs again. How quickly is the market translating ESG requirements into an understanding of actionable projects that they are willing to undertake in the near term?
So the question was how quickly?
How quickly is the market translating ESG requirements into an understanding of actionable projects?
It's happening right now. I mean, we have projects that we're working on right now, and they fall into numerous categories. I mentioned one. Another is LDC. You already know about a Muni, but there's an LDC that we're working very closely with. This LDC has a behind the gate, rather large company that seeks to be able to roll out a green hydrogen utilization to a number of different plants.
Right.
This is they're all over the green hydrogen. And it's not just a matter of kind of doing the right thing or economics. It really does help them. gain uplift in terms of revenue, and it also alleviates the need for carbon credits, having to purchase carbon credits in order to qualify for the ESG and enhance their score. So it's really, there's a lot more economics going on besides just the greenium. There's also the uplift in terms of offtake, and there's alleviating the need to purchase carbon credits that all go kind of hand in hand when evaluating these. So there's a lot that are moving forward.
So you kind of touched on this, but you got a question specifically to you that says, what are the most prevalent types of hydrogen deals that New Energy is seeking? Or seeing, I'm sorry, not seeking, seeing.
Well, you know, the repowerings are big, behind the gates, and LDCs are big munis in terms of repowering. I think I'm missing one. Ken, what am I missing in terms of categories? Major midstreams. You know, all the way from kind of the smaller guys to the majors. We're working with a couple majors that really do seek to roll out kind of a green hydrogen PER solution to scale. It's literally the horsepower is in the millions. I mean, it's pretty magnificent in terms of you know, what we're doing. Now, the complexities are associated really with passing along that, you know, any cost or seeing instead of a nat gas type recovery, it gets into hydrogen and gets into other factors. But and then there's the utilization rate for the variety of meters and compressors and the like, all of which, but really a big factor there is, you know, who's around it. And if you have an oxygen plant, you know, there's a lot of off-takers who want oxygen. That's a tremendous uplift. I'll just expand one more thing, and we're working on a South American green ammonia plant. And this happens to be at altitude where there's some significant economics associated with PV, you know, photovoltaic, solar. And that oxygen, as you can imagine, this I can't really disclose. If I disclosed the altitude, then it would probably give away where it is. But oxygen is a major off-taker, it's a major uplift, and there's a big market for oxygen right now with the medical facilities and the like.
Great, thank you. All right, Mike, back to you. Looking for a little bit more detailed on some of the slides that you presented earlier, mainly like equipment cost, O&M details, and then ideal pressure drops and flow rates.
Yeah, so we have information on this in document form, which I know is always more helpful. So whoever asks that, I'm happy to exchange emails and send it. High level, what we're looking for in terms of operating conditions are we're looking for inlet pressures anywhere above 400 PSI. We're looking for a pressure ratio, which is your inlet pressure divided by your outlet pressure, above a 1.3. And we're looking for really as much flow as possible. But we'll evaluate any site with you know, north of 15 million standard cubic feet per day. In terms of O&M, this is something that we're really proud of. So, you know, my colleagues who have driven the design of this technology come from the maintenance space of electrical motors and generators. So they understand how to minimize the maintenance on this, this rotating equipment. And we've designed this from the ground up to minimize the O&M expense. And what that means is the only O&M expense that needs to be covered over the course of the year is really coming out and doing things like cleaning strainers, making sure the gauges are running efficiently, and that's due to some of the innovations we made around things like active magnetic bearings, right? So there's no wear parts, there's no gearbox, which, you know, anybody from the wind industry will tell you gearboxes are a total nightmare, right? Especially with variable speeds, need to be rebuilt every couple of years. And then the last thing I'll mention is, you know, you mentioned cost, capital cost. We are highly flexible in terms of our business model, right? We recognize that we're going to make it easy for our customers to work with us. So Anax is fully comfortable with financing, building, installing, operating, monetizing the system, handling everything from soup to nuts. And then we're comfortable paying an annuity to the pipeline company if they want to take an annuity and take the renewable energy credits. At the other end of the spectrum, we know there's customers that want to deploy capital, and we're happy to sell the technology to the customer with a confirmed maintenance agreement, an annual maintenance agreement that covers everything soup to nuts. Think of it as the elevator model where you pay that fee, and then over the 25-year life of the equipment, you're covered for any breakdowns that happens. So I can follow up with more detailed information. There was a lot packed into that question, but hopefully I...
Well, you get the last one too. So the question is around scalability. Is it possible to start with a small-scale pilot project that doesn't use the full pressure drop and then later scale up once the solution is proven? Is there a modular scale-up potential?
Yes, I mean, and I touched on this earlier, but I think, so I won't repeat myself, but what I will say is that that is exactly how we want to operate with our customers, right? And we're working on a couple of different projects right now. All of them can support at least 2 turbo expanders. In all of the projects, the way we're looking to work together is to start with just 1. Get everybody comfortable with how that's working, and then gradually work our way up to the optimal system size. Now, there's some installation provisions that need to be made, right? You don't want to install the first unit and then, redo all those costs for the second unit. You want to recognize some economies of scale. So that site in Indiana I was talking about that can support 12. The way we want to work with that partner is we want to make all the engineering and design improvements for the 12 units, but we're just going to start with 1 or 2, right? And then we're going to scale up from there.
Great. Well, that's it for the questions. Please join me in thanking the panel for doing a great job in presenting. Thank you, Rakesh.
Thank you.
All right.